Okay, example 5 will be similar to example 2 that we did earlier, except now we have an amplitude of 2, we have a period of 2 pi, we have a phase shift in this problem of 2 pi over 3, and we have a vertical shift of -5. So write the sine function. Now, your homework is going to say write two sine functions, so that's going to be positive and negative, an amplitude of 2. So I'm going to put a 2 in front of my sine. Now, I like to put a bracket here because I want to write this in factored out form. And so what I mean by that is I want to be able to write my b here and then put my x here with my phase shift there. And then my vertical shift out here. So this is going to be my b, this is going to be my phase shift, and this is going to be my vertical shift. And I'm going to erase those things at the end because I don't want to see those types of things show up in your answer necessarily, but this is just a good way to see where these different things are going to go. So first thing, easy, plug in the vertical shift. So that's going to go down there at the end. You can plug that in, no problem. So your vertical shift is done. The next thing is, because we're writing it in factored out version, this is going to be easy to just pop in the phase shift. So minus 2 pi over 3, and that takes care of the phase shift, and everything is good to go there. The last thing we need to plug in then is b, and that is not given to us. The period is given to us, but b is not given to us. And so just like we did on the previous examples, we've got to use this formula to find b, and so I'm going to plug in my given period of 2 pi and set that equal to 2 pi over b. This is the same thing as 2 pi over 1. So when I cross multiply, that's going to be 2 pi is equal to 2 pi b. And to get b by itself, just go ahead and divide by 2 pi, which will give you b is equal to 1. And so you're going to put a 1 there. Obviously, that doesn't do anything. And so you could just leave that off in this particular problem. But again, this is a nice way to do this so that you can just plug in your phase shift, your vertical shift, without having to think about, what it'll look like if it's not factored out. It's much easier to write it in a factored out version. Okay, last thing here is that I've given you a graph, and I want you to write the equation of a sine function and a cosine function. And so let's take a look here. Notice the thing I've been saying basically this entire lecture is that the sine and the cosine function are nearly identical. The only difference is those order of points. And so what helps determine the order of the points is the phase shift. And so that's going to be the only difference between the sine and the cosine function, is that phase shift. And so the amplitude is going to be the same, the vertical shift is going to be the same, and the period is going to be the same. And remember, that period is going to help us figure out what b is, so that we can write our function. And so all of those things are going to be exactly the same for part A and part B. The only difference is that the phase shift is going to be different for both of them. So let's take a look here. Amplitude, remember, is the distance between the midline and the maximums and the minimums. So I'm going to take blue pen here, since we want it to be a different color, and figure out where those zeros, quote unquote zeros, are located. Where is the middle of this graph? Well, it looks like, unless my eyes are getting bad, that it's at y is equal to 4. And so that is going to be my midline, which, by the way, is going to make that my vertical shift. The vertical shift is always your midline. And so I'm going to write that here just to help you, that the midline is your vertical shift. The amplitude then is the distance between that midline and the top and the bottom of the graph. So it's going to be this distance and or this distance, and in either case, you're going to see that that distance is 2. And then finally, the period. The period is how long it takes to repeat the y values. And so if you start over here at this point right here, how long is it going to take you to get back to a point that looks like that? Well, the next point that's a maximum is right there. And so we went from -4 pi until 4 pi. And so what is that distance? Well, you can just take the end point and subtract the starting point. That's one way to do it, and that's going to give you a period of 8 pi. We need to use that, though, to find what b is. And so we remember that p is equal to 2 pi divided by b. And so I'm going to plug in my 8 pi here and set that equal to 2 pi over b and go ahead and cross multiply. So that's going to give me 8 pi b is equal to 2 pi, and then divide by 8 pi to get b by itself, and you're going to end up getting b is equal to 1/4. Okay, so we have our b, we have our vertical shift, we have our amplitude. And so now for the sine function, I'm ready to essentially write this entire thing. This is going to equal to y equals my amplitude, which is 2, sine of open bracket. I'm going to go ahead and put my b, which is 1/4, x, and then on the inside of that, my phase shift, which I haven't gotten to yet, and then at the end, my vertical shift of plus 4. And my cosine graph is going to be exactly the same as that, except instead of writing sine, I'm obviously going to write cosine. And I'm not ready to figure out what the phase shift is just yet, but now I am. And so let's do the sine function first. I'm going to go ahead and erase everything that we have on this graph, if I can, so that way we can kind of start fresh. And we are looking for a sine graph. And so remember that sine functions begin with a quote-unquote 0. So we're looking for a point that is on the midline. And then it would need to go to a maximum. And so, for example, if I were to choose this point right here, which is on a midline, it wouldn't be a good choice because then the next point would be a minimum. And so that's not a good choice unless you want to write a negative sine function. I will allow you to write a negative sine function if you want to, but I'm going to try to write a positive sine function because you guys already know that I'm a positive person. And so I'm going to look for a point on the midline where the graph would then go up to a maximum. And so that is going to be right here starting at 2 pi. And so remember that initial point is always the phase shift. And so therefore in the parentheses here, we're going to put minus 2 pi so that the graph will go to the right 2 pi and start at 2 pi. Okay, for cosine, we're looking for a maximum to get us started. And so you've got two options for your maximum. You could either start over here at negative 4 pi, or you could start here at positive 4 pi. So either one, perfectly fine with me. If we do it at negative 4 pi, that means that on the inside here, we would have to say x plus 4 pi. And so notice, the only difference between my answer in A and B is that phase shift. The phase shift that we used here was 2 pi. The phase shift that we used here was negative 4 pi. And everything else, the amplitude, the vertical shift, and the B were all the same for A and B. So that's going to do it for sine and cosine. If you guys have any questions, please reach out to me, because if you do not understand sine and cosine, it will be very difficult to figure out what secant and cosecant are doing, because secant and cosecant are essentially sine and cosine graphs with one extra step. And so if there's something here that does not make sense, please email me, reach out to me, and let's get that figured out.